Welcome to Relay Chain, a podcast produced by Parity Technologies where we discuss all things substrates, Polkadot, and Web3. Today on Relay Chain, we have Sergey Nazarov from Chainlink. Hi, Sergey. Can you give yourself a quick introduction?
Yep. Hi, Joe. Thanks for having me. I'm one of the people who works on Chainlink, which is a decentralized Oracle system. I have been building smart contracts for, I think, approaching 7 years now, mining for a few years before then. So I've spent a lot of time in the cryptocurrency, blockchain, and smart contract industries and have seen them change and grow. And I'm very excited to see where they're going now and very happy to be working on them with so many great, smart people.
Great. So could you give, before we dive into some of the nuances, can you give an overview of Chainlink and what you're doing?
Sure. So what Chainlink does is it creates a decentralized Oracle mechanism. What that means is just like a smart contract is highly reliable because the logic in the contract is computed on multiple independent nodes, which is, quote unquote, decentralized computation. You now see people building contracts which not only need to run logic on chain, but you also see them building contracts that need to interact with external systems. Now, it's not super widely known that there's something called the Oracle problem, where the logic you write on chain in a blockchain or smart contract network is not able to speak with external APIs. And that's for security reasons and all kinds of consensus reasons related to how blockchains and smart contract networks secure data. Now, that's fine if you want to generate tokens, because tokens are a very clear native capability of blockchains because they're essentially used to compensate miners, and it's just kind of the native capability. And so that's what the space is about, generating tokens. But the reality is that a lot of financial products, like what people are now calling DeFi or decentralized finance, are actually products that need to be triggered by external market events. So a certain market price needs to be known to settle certain contracts. Lending markets need certain Oracle data about how they should pay out their interest yields. All the different derivatives markets need all kinds of market prices to determine how they should settle. And this DeFi space that's growing now, and as well as insurance and certain pieces of fraud-proof gaming, needs something called an oracle. Now, an oracle is essentially a system that sits external to a blockchain in parallel to it, and it seeks to provide the data that a blockchain or a smart contract can't get. But the issue starts to become that while you're trying to expand what a smart contract can do, you are also creating attack surface area by allowing these external systems to essentially control the outcome of the contract based on the data they provide to it. And this attack surface needs to be secured, and it needs to be secured in a decentralized way if you plan to call that smart contract, truly decentralized financial product, or smart contract insurance in the sense that you have the smart contract guarantees of reliability for the insurance product end to end. So what we make is we make something called a decentralized Oracle network, which is essentially synonymous with an extremely secure Oracle mechanism on the basis of decentralization. So we're basically extending the security model that secures the contract code into this Oracle mechanism, such that if you want to expand beyond making tokens into financial products that need market data, or insurance products, or something with trade finance, or certain types of fraud-proof gaming, and you need external data, now you have an infrastructure to write the contract code, but you also have an infrastructure to connect that contract code with any external data source, and you get two key properties. You get the same security guarantees as the smart contract code, the same, close to the same or the same. And you also have an extreme level of ease of use where, just like you didn't need to build a piece of infrastructure to write smart contract code, and you were able to get that done relatively quickly and efficiently and still maintain security, now you can quickly and efficiently and securely connect that smart contract code to any external input, market data, IoT data for insurance, shipping data for trade finance. And that connection is also not a burden where you need to build infrastructure because the reality of building infrastructure is it has a lot of its own nuances around cryptography, DevOps, implementing security models, which is distinctly different than building a use case or a dApp or a financial product that is usable by private key holders that have cryptocurrency. So there's really in the future, I think, no need for dApp development teams to stretch their already limited resources on both the dApp they're building and the creation of infrastructure. There's been a lot of innovation on let's make sure that the logic and the contract code can live in an environment where the developer doesn't need to worry about building infrastructure. And now that people are expanding into these other forms of smart contracts, we think the same thing should be true for the infrastructure that essentially defines the second part of their contract, right? So the correct way to think about this from an architecture point of view is you have one part of your contract, which is the on-chain code, and you have the second part of your contract, which is the off-chain code. And the off-chain code it needs to be equally secure because it has a large amount of control. And this can be seen in the history of Oracle failures in the blockchain space, not related to our product, but related to either home-baked oracles or other systems, where if somebody had highly audited smart contract code, but they didn't have an off-chain Oracle mechanism that either went to the right data source or got data aggregated the right way or was secure in and of itself, they had a huge attack surface which people exploited. So the thing to remember is what you're doing when you're making DeFi products or smart contract insurance is, yes, you're making a smart contract because you're using on-chain logic, but you're also expanding what you define a smart contract as. And that expansion into this off-chain realm of data delivery or randomness for fraud-proof gaming or any other set of off-chain resources needs to be equally secure if you expect that contract to hold large amounts of value.
Yeah, so you alluded to this a little bit, like with off-chain logic and like end-to-end logic here, but you have this weakest link problem. And can you maybe just like go a little bit more in depth on that with like current oracles and how you have very strong backend with the blockchain and smart contracts, but there is this weak point of where the interface actually is and this data is coming in?
Yeah, sure. Glad to clarify that. I think the useful way to think about this is what is the security model of the blockchain and the smart contract industry? I mean, the security model is basically decentralization, which equates to multiple independent node operators redundantly computing the same computation, providing cryptographic proof about the outcome. And that extreme redundancy is really the security model for reliability, liveness, and correctness of the computations, right? So I think the thing to really think about is if you have a highly decentralized smart contract network, properly computing on-chain logic, and then you connect that on-chain logic to some kind of, homemade or whatever weird Oracle mechanism, which, by the way, if any user ever asks, you won't be able to show to them because, why would they trust that? But even more importantly than being able to show the user and gain their trust, you have a very serious security risk. That's why the user can't trust it, because you essentially have centralized control over that contract's outcomes on a second-by-second basis. So while you've created decentralized computation or automation about a part of that contract's functioning, there's a whole other part of it that is still completely centralized, whether you use a centralized Oracle service that's a service, or whether you make an Oracle you control, or any collection of these things. And the reality that is just simply antithetical to the security model of our space. And so if you believe in the security model of our space and the reliability and the guarantees of our that security model provides, if you believe in decentralization as the right way to provide all these security and liveness and reliability guarantees, correctness guarantees, then that should extend all the way to both the Oracle mechanism. So you should have multiple independent node operators validating an input to a sufficient degree. In Chainlink, you can always increase the amount of Chainlink node operators as the value of the on-chain logic and the value that it controls increases. You can increase the amount of security you have in this Oracle mechanism, right? This kind of abstraction layer, data transport layer, where you validate that an input is sufficiently accurate to trigger something of such deterministic and kind of immutable value. And then this should also extend to your data layer. So you should actually have a capacity to talk to multiple different data aggregators that smooth out all kinds of risks. And you should have high quality data feeds feeding into a multitude of nodes I'll give you an example from our price reference data networks. For price reference data networks like BTC USD and other networks, we have somewhere in the order of 21 nodes pulling from 7 data providers. And those data providers are not direct exchanges. They are data aggregators that smooth out all kinds of risky market events to make sure that the data is more or less correct. And then that's reported by, each data provider has its own quorum of nodes that report it into this larger aggregation. And then you have, you have decentralization at the data layer, at the middleware layer, and that's when you have this decentralized kind of guarantee, this decentralized security guarantee on this kind of external systems level. And once you have that and you pair that with the on-chain decentralized security guarantee, that's where, in our understanding, you have a truly decentralized financial product or insurance product or trade finance product or even gaming product. That's when you've truly applied this security model end to end. I mean, that's what our space is about. It's about the application of that security model to all kinds of data, ownership data, contract data. That's really what our space is seeking to accomplish. And I think thinking about it in this holistic end-to-end manner is both correct from a security point of view, and it's also correct from the point of view of being able to explain to a user of your decentralized application, why is it decentralized? And I can assure you from my experience that users with any real value to put in these applications will begin to ask that question more and more. And then if certain decentralized applications fail because they were not decentralized end-to-end, because, say, the Oracle mechanism failed for whatever reason, then these questions will only increase. And so my advice is, if you're architecting a decentralized application, I would architect it as a truly decentralized application, or at least have that planned for whenever you try to put significant amounts of value on it, hundreds of thousands, millions of dollars. By then, you should be able to either make a claim about this or have a clear roadmap for how you would consider this a truly decentralized contract or product.
Yeah, I agree that we're going to see more of these contracts with this weak link being exposed when they actually fail. Just to reiterate what you said to make sure that I understand, you could have a very robust set of logic that's going to be deterministic and always execute on chain. But since that logic is public, if one person has the ability to just inject whatever input into that logic, then they can basically get whatever kind of output that they want. And the logic isn't really that useful anymore.
I mean, it depends on the logic, and it depends. People have all certain fallback mechanisms and arbitration mechanisms, and it depends how quickly that logic can move value to different players in a market, how leveraged the market is, how much value is in the market, right? So that creates incentive. So it definitely depends what kind of logic you're talking about. But generally speaking, I would say that if you build decentralized financial products or insurance products, they are essentially based on these inputs, right? It is very important to write that code correctly and cleanly and securely and get it audited, and things like the DAO have shown us that. But I think it's equally important. It's going to become clearer and clearer that it's equally important to make sure that this Oracle mechanism providing the inputs is also secure. So I think you can write certain things into your contract to mitigate risks, or maybe you can set a limit on how much value is in a contract, or you can always try to mitigate some kind of risk, but that is not really a solution. The solution is not, my DeFi market will never grow beyond $500,000 or something like that. That doesn't really make sense, right? Or I'm gonna manually lock up the contract if there's a problem. Well, it's a blockchain-based world with immutable, irreversible computations that if somebody steals a bunch of money from an exploit related to an Oracle, maybe you won't have time to go and hold a big vote and decide that we got to lock it all down, right? I don't know what process you have in place for that, but so there's definitely ideas on how to mitigate it. But I think the real answer is that you should seek to architect something end to end that provides you the security guarantees that you want to show your user, and that that high level of reliability and liveness and correctness that our space seeks to attain. And you should just seek to attain that end to end, probably under the assumption that your contract will indeed hold large amounts of value. That is my recommendation.
Yeah, so when we go beyond these very simple tokenization applications and start talking about larger applications, and you've talked about Uber in some of your other conference talks that you've given, that you're going to have some sort of off-chain data like GPS going into this. And then for DeFi and insurance, there's going to be some real world event that triggers an on-chain event. Can you talk about any other applications that you guys have seen with Chainlink?
Yeah, I mean, we see a lot of applications. I think the places where I'm seeing the most movement are decentralized finance. That's a fast-growing space because you're starting to see people have gradual success because there's now enough private key holders to pay or put value into those products. And so people can make a successful DeFi product. Fraud-proof gaming and its use of randomness and things like that. There's demand there. There's demand in smart contract insurance, though that industry moves slower. And then there's a lot of demand also at the enterprise level. At the enterprise level, it's a slightly different proposition where what you're trying to do is you're trying to kind of make a hybrid model between the existing systems of an enterprise or the enterprise systems that people are used to using and the on-chain smart contract logic. And we've done some interesting work with Google on that, and we've seen people take that architecture and already start going towards production to take the capabilities we have where you can basically write some off-chain logic that goes to something like Google BigQuery, gets certain amounts of data, whether it's about on-chain data or location data or price data or any amount of data that's processed off-chain.
And this might be from like a normal database.
Right. This might be from existing enterprise, level infrastructure, and that's because you can't necessarily process a lot of what you want to process on chain. We're also seeing a lot of interest in scalability solutions. One of the really cool things that we did recently, actually here at the hackathon, we released collaboration with folks at Arbitrum, where we were able to make it so that Arbitrum computations, which make Solidity and soon other types of code more scalable in its computation, and we were able to get those computations to work on a network of Chainlink nodes. And so I think what we're really seeing is that there are all these barriers that people have to building smart contracts that go beyond tokenization. And those barriers are data delivery, interaction with a lot of existing resources in the enterprise backend and enterprise grade kind of cloud systems, as well as the capacity to do trust minimized off-chain computation in a way that scales and brings that data back onto an on-chain environment like Polkadot or whatever kind of environment. So I think across these are the three main directions, and then there's obviously vertical interest, different levels of vertical interest in each one.
I think like the off-chain computation part is particularly interesting, just because my own background is in like time series analysis and sensor data. And so how have you dealt with some of this like less deterministic data? Because, sometimes sensors fall off or they go out of calibration. And what methods have you seen for deciding, hey, is this data good? What should we do with it? Should we actually take an action on chain or not?
Yeah, I think there's three nuanced points there. I think the first nuanced point is that there are environments with multiple sensors, a lot of redundancy. I think that environments that don't have that, but where it's relatively cheap to create more sensors, will do that once those sensors underpin enough value. So in space shuttles, you have a very large redundancy of sensors because it's extremely costly. And you even the final sensor that's doing the readings, you have multiple sensors doing that reading. That's because space shuttles cost a lot of money and sensors don't cost a lot of money, right? So in these environments, we're like insuring a solar panel field, for example. If it's relatively cheap to generate more sensors and the people who are selling the solar panel fields can provide you a better insurance policy that's worth a couple of $1 million to them or to you or to somebody in economic value, then yes, people will spend money to implement sensors. I've already seen many insurance companies show up to customers that they're going to insure for in all kinds of insurance related to industrial kind of operations and factories and boilers and all these industrial systems that have huge value and huge kind of calculations with depreciation. I've seen the insurance company come and at their own cost implement sensors to generate data to properly price policies for their clients because the sensors are so cheap. So on the one hand, I think, yes, there are certain situations where you have redundancy of sensors. Great, you have redundancy of sensors. That's a lot of data sources. You can get essentially a decentralized picture of a real world event. Let's say you don't really have that. Well, once there is an economic reason to generate that data, and the sensors are cheap, then people, I think I've already seen through the insurance industry, going out and implementing sensors as a result of that economic kind of incentive. The second thing is that the second nuance is that if you don't have a capacity for whatever reason to generate a redundancy of sensors, then what I've seen people start to do is I've seen people start to go towards making the device that creates the sensor data more and more complicated, more and more basically heavier. And a lot of it is focused on signatures. So if you can get increasingly large levels of guarantees at the origin of a single IoT sensor device, those guarantees can be useful. So that requires you to start kind of jacking up and increasing the capabilities of that device, right? So that's once again an investment. So you have two approaches. You can create a lot of devices for cheap, and you can get a picture that way. Or if you can't do that for whatever collection of reasons, you probably start swapping out for more security-focused IoT devices, right? And this brings me to the third nuance. The third nuance is that all of the logic that you want to encode about how an oracle mechanism, you can do trust minimized computation off-chain about sensor data, which means that the sensor data, the off-chain computation, that it can happen in a trusted execution environment, or it can be done using something like Arbitrum, which is a very interesting approach, which we're pursuing more and more now. Or it can be done in an Oracle network where it's redundantly computed. So you can have trust minimized computation where you define conditions around the threshold of reliability or validity that you want all of these sensors to meet. And once they do meet all of those high thresholds, only then do they need to go to the contract. Now, the beauty of that is that you don't need to write all of that on chain. So to a certain degree, you get some privacy, even though that's some amount of security through obscurity, which I generally don't believe in. But you can keep that private, and you can make those list of conditions large and complicated, avoiding on-chain costs and still getting trust-minimized off-chain computation. So I think between these three approaches, sensor data can definitely be very useful. If I had to really guess about which one I think is going to go forward the most, I think people are going to generate a lot more sensor data from a lot more sensors, especially once insurance policies start getting written more and more around that data. And it's probably going to be the insurance companies that go out there and make that happen. And then the capacity to validate data from sensors is also going to improve and improve and improve, such that maybe that middle approach where you really have to invest a lot in making a really heavy, jacked up kind of like secure signing device is less. And so I think those are the things that I see there.
All right, so I want to transition a little bit away from the tech and more into the philosophy of blockchain. And you said that blockchain will provide a better way to organize society. And I was wondering, can you elaborate on this and what led you to this realization?
I think this realization came about more or less when what you could mainly use was Bitcoin. So you had Bitcoin and you had Bitcoin multi-signature. And that's pretty much the only functionality that was really out there. And people were kind of talking about these protocols that had smart contract capabilities and DEXs and stuff. And that was very, very early. So this realization was, I don't know, around 12 or 13 or 14 or sometime in that time frame where it really hit home with me. I think the realization really was that the guarantees that society provides, even about ownership, when you think about it from just Bitcoins, if you're living a Bitcoin-only world, the guarantees that society provides around ownership, when compared with Bitcoin guarantees, are laughably weak if you actually look into them. Like if you look at how certain things are insured at banks or something, that there's, things like basically all kinds of things that if you really look into how ownership is guaranteed to people, you'll come to the realization that it is extremely, extremely weak. And the reason people don't really feel this or think about this is because they're not getting hit with it, is the reason. But the guarantees of Bitcoin are orders of magnitude better. So I think that was fascinating to me. I was thinking about how that fits in, and then I saw this really interesting thing that people were building. I think this probably pushed me over the edge here, was that they allowed people with feature phones in all kinds of places where telecom systems just went about. And you had these really cheap, that's when, it was around the time when feature phones really dropped in price. And people all over the world, emerging markets, got feature phones. Like places where they hardly had electricity, now the guy can have a feature phone. And this feature phone, that's like the flip phones, the clamshell phones. This feature phone could have a Bitcoin wallet in there. And it could even have multi-signature. So now this guy in some place that doesn't have a bank, doesn't have any way to store value, can not only store value in this feature phone, but he can actually implement a multi-signature scheme between him and like the village elder or whoever he wants to do business with in the other village. And he, thanks to the telecom network and thanks to the internet, can now send value and hold value and store value. And with like today's DeFi products, he would be able to earn value at a savings rate that's superior to most developed economies, without anybody doing anything. Like technology did that for him, right? For these people. And he doesn't need for a bank to come. And even if a bank comes, I mean, a lot of places, those guarantees, the thinness of them is exploited. In developed markets, it's not exploited because the legal system works. Even though the guarantees are thin, it's still not exploited because the legal system will enforce them to a sufficient degree that it's not worth it. It's not because the guarantees are very firm. It's because of this game theoretic dynamic in developed markets with a working legal system. Places where the working legal system doesn't work, people exploit this thinness of guarantees from traditional society. And that's why a lot of people in those environments, I mean, billions of people at this point, I think it is billions, don't have certain bank savings capabilities, don't have the ability to transfer money. They can't get insurance against rainfall for their crops. Where a lot of these financial products, they didn't start out as some way for people in nice suits to make more money. They started out because people needed to hedge risk against rainfall and whether the ship could sail across an ocean to discover, whatever it needed to discover. I think it's really both the capacity to improve things in the developed market, but really the places where you see, where you're going to see the largest impact from this technology is all these places where, people didn't have a phone and now they have a phone. People didn't have a lot of stuff to read and study and now they have the internet and they have Wikipedia. People didn't have a bank and they didn't have an insurance company to allow them to make a basic derivatives kind of futures bet on the value of their crop and therefore not have to have their farm fail because of bad rainfall, right? These are not trivial things. The only thing is that in developed countries, they're very well explained and hidden until a systematic issue that triggers enough of these thin guarantees to fail arises. That's what people call like a financial crisis or like a cyclical downturn or, whatever they want to call it. But I think the thing that put me over the edge is that not only are the guarantees so much firmer, if expanded to the relevant kind of stable currencies and different products that these people can benefit from, everybody can benefit from that, right? You'll have less cyclical downturns in developed markets because things will be more transparent, right? If during 2006, 7, and 8, you had something called a smart mortgage where all pieces of data about every individual mortgage holder was appended to a single smart contract that traveled between the issuing community bank to the commercial bank to the kind of the investment bank that securitizes things, all the way to the hedge fund managers, and people could research back down into each individual kind of person in that basket. Well, that whole thing would have been a lot softer. It might not even have happened because the only people that were able to figure that out were people who had to surpass massive amounts of friction to get that data because there was no way to transfer that data across all these different counterparties. So that's in developed markets. I think it can make these cyclical, systemic, risk-based events much softer, which is on the one hand for people that make money from that. Maybe that isn't in their interest, but I don't really care about those people. I'm not one of those people. I don't. I'm sure those people have made a lot of money and they'll be fine. I think, minimizing the systemic financial risk of a global financial system because it works more efficiently, which is what people seem to say they want everywhere you turn, except the ones that are quietly making money from the lack of that. That's a huge benefit. And then the benefit to emerging markets where people go from 0 to 1 on a multitude of all kinds of capabilities in terms of financial products, contracts that people in developed markets take for granted. I mean, if you really think about it, like imagine you couldn't save money. Imagine you had huge inflation. Imagine you couldn't transfer money. Imagine you couldn't insure yourself against life-changing events, right? These are very significant things that affect a lot of people that they don't have a way to deal with because their local legal system can't help them deal with it. And I think it's absolutely amazing if, even in a few decades, our industry creates the technology that allows these people to deal with all these situations in a dignified, fair manner. I think that, as a body of work to sink your life into, I think that to me sounds quite worthwhile.
Yeah, two things you said were actually really interesting to me. One was that it took you about like a period of 3 years to come to this realization. And I feel like so many people have this, story about how they heard about Bitcoin and then they just immediately like went down the rabbit hole. But it was like maybe 14, 15, 16. So I was 2 years shifted to the right than you. But also like it took me a long time to start to realize this stuff. And the other was just that like you made the jump so early from just like the finance and like, be your own bank into all these decentralized products of like insurance. And that's people in rural areas, they might not just lack access to banking, but they actually lack access to all the other financial infrastructure that would be really beneficial to them.
Yeah, we worked on really cool stuff. And even in 2015 and 16, we had these things we were working on where people, smaller producers of meat in, where was it, Swaziland or all kinds of places, they could ship meat and the meat shipment could be tracked and the temperature of the meat could be tracked. And then when it arrived and cleared customs, they could get automatically paid in Bitcoin. The problem was that when we looked at them getting paid in Bitcoin, there was no exchange for which they could convert Bitcoin to their local fiat currency, to run their farm or wherever they produce this meat. So I think the fascinating thing for me has always been taking this whole industry for years now, going on, I think, 6-7 years now, taking the industry towards, or helping the blockchain industry and the smart contract industry really become about the dominant form of digital agreement. So there's all these digital agreements. They fail in developed markets, creating this systemic financial risk, harming lots of people while making a very small amount of people rich.
The incumbents actually profit from the inefficiencies here.
Yeah, I mean, that's the reality. You can't say that these people aren't, they can't go out and say like, these efficiencies have made me amazingly rich because I know about them and that there's no clarity about what I should do or not do related to them. And so I do these things, and who knows, right? Like, I don't know how involved the CDO manager was in some of these schemes where people profited. What happened? I don't know what happened. What I do know is that why does that situation exist? There's no need for it to exist. And the reality is that I and all the people I work with, we work in an industry where we have a very clear technical path for that situation to no longer exist. So it's just going to become a moot point. Did you exploit it? Were you going to exploit it? You can't exploit it. It's just going to be like one of these systems that it's very difficult to exploit. It's not worth doing. Go find something else to exploit. And the developed market economy doesn't have huge systemic booms and busts because people can't exploit this to such a degree. And emerging markets have all the things that people in the modern world realistically should have, right? Bank accounts, a way to insure against catastrophic events, ability to transfer value, securely hold value in whatever format they want to hold that value in, combat inflation. Makes perfect sense to me.
Yeah, so this kind of is already answering the next question that I had. Something you said in the CoinDesk piece was that blockchains are infrastructure for helping people to make their own thoughtful decisions about their life and their economic self-determination. I just want to make like a counterpoint so that we can dive a little bit deeper into that, which is like, in like surveillance capitalism, or like Zuboff's book anyway, was a lot of like big tech and like algorithmic infrastructure actually limits people's self-determination, where it's kind of pushing, it wants you to take a certain action and it will feed you information to kind of corral you into this. And what do you think about actually designing tech that doesn't reinforce behavior that certain people want and actually does give people more economic self-determination?
Yeah, so I'm not a big user of social media myself. I've never really used Facebook. I tried it once. Basically, they made this cool open graph thing years ago for semantic web, and I got really interested in that, so I played around with that. I don't really use social media because it doesn't seem to create the conversations or the relationships that are very firm or very meaningful in my experience. So I don't use Facebook or any of these things. I didn't use the early versions of these things. So I'm perhaps not the best subject to ask. What I think will generally happen is that even if corporations and their economic interests convince people to take a self-detrimental course for a brief period of time, right? Like with fast food or with all these different foods that like people are just eating and it's bad for their health and they're eating it, or some kind of financial products or something. Eventually, what I've seen in my short time here on Earth is that people adapt to that. You can't really do that for too long. So even that you're asking me this question and that I'm not super a part of that debate or am not particularly active in this question tells me that just like maybe a decade ago, many people would have been like, organic, what is organic? Why do I need organic? GMO sounds good. Like now the average person is relatively thoughtful about that because I don't think people in general are going to take, especially not in like a free press kind of, here's a bunch of solid information type of place like the US and a lot of Western countries and basically all the countries over the world now. I don't think that the likelihood that corporations can just perpetually take people down a self-detrimental path is particularly high. I don't think people are that stupid. I think soon enough people realize that, like certain things and certain foods are not good, or certain behaviors that corporations want me to do because it's in their interest are not in my interest. I'm not going to do those behaviors anymore. That just seems like a logical conclusion. The people who are building technology that will create the alternatives for those people that make that decision, I think that the reality is that in many cases, those people are going to have to wait rather than choose the perfect moment. And even if you look at the history of some of these other things like Whole Foods and some of these types of things, a lot of these started out for a very niche group of people who you could call them early adopters or forward-looking or whatever, but really they personified a certain logic that most other people eventually came to. But the people who made the resources that this group of forward-looking or different people use, it's a difficult thing because I think the people who make these systems, they really need to have long-term conviction. And it's very difficult to predict when society at large will get fed up with a certain set of corporate interests. I can't predict it. I have no idea. I don't know, right? Maybe a documentary does it. Maybe something else does it. It's so difficult to predict. So I think that's one of the big challenges that people like that have is that it makes a lot of sense to them. It makes a lot of sense to the people that surround them. And so it seems very obvious. But the rate at which it's going to become obvious as like a personal choice to the larger public is difficult to predict. I don't think this applies as much to blockchains and smart contracts and all these different DeFi things, because these things have an economic incentive. So they basically say, I know plenty of people in the Bay Area and Silicon Valley who are like, I can earn 6% or 8% in DeFi products. Man, interest rates just went down. I can't even get 2% anymore from a bank. And so it doesn't matter what they think, right? It doesn't matter what documentary they saw. It doesn't matter what their friends think. Pure economic impetus, once these blockchain-based systems reach a sufficient level of economic incentive, people will simply adopt them. Even if you believe in behavioral economics, even as moderately rational economic actors, they won't really have a choice. Nobody is going to keep earning 2% while everybody is easily earning 8%. That's just not realistic. So I know it's funny that I say that these other people have this problem for their innovative technology and I don't have this problem for my innovative technology, but I think that is a significant difference, the incentive to use the products that come out of the blockchain industry.
Yeah, I mean, that's quite an optimistic outlook. And I mean, I share it. And we've seen like the New York Times has been for the last few months running a series on privacy and surveillance. And so we are seeing the major information outlets starting to get these concerns out there about some of the bigger tech companies.
Yeah, I don't know enough about that. We made a secure messaging service once, and we didn't continue with that because I had a sense that a lot of the people that wanted to use it would not want to use it for the best thing, so we didn't super go in that direction. But I think the average person will come to realize these things, and then the ease of use of the alternatives will be very important. And I think once, there's going to be, in terms of a graph, there's going to be a point where those 2 points meet. And after that point, there's going to be inflection, and you're going to see a lot of adoption. When that'll happen for this category of problems, I'm not super informed about.
Right. This is like a black swan thing where you kind of know this thing is going to happen, but you don't know if it's going to be in 5 years or 10 years or 15 years.
Or tomorrow or a month, a year. I don't really spend a lot of time on these. I'm basically spending pretty much almost all my time on what I'm building. And that's kind of just the way I've decided to pretty much go through life, which I'm pretty happy with that decision, because I'm not perpetually distracted by other things, which I think is a big problem in modern life, actually.
Yeah, absolutely. I wish we had more time to talk about that, but we're running low on time. Can we wrap up by going back to what you are building, Chainlink, and talk about your integration efforts on Polkadot?
Yeah. So I think we've been working with Web3 folks for a long time now on how we can get Chainlink and good price reference data and all kinds of things that DeFi smart contracts need onto the Polkadot network. I think a lot of that is coming to fruition now. We've had a good amount of help from the Polkadot team and some of their engineers who have been kind enough to help us make sure the integration is properly done between Chainlink's ability to provide on-chain data, certain off-chain computation, and all the capabilities that developers would need on various parachain substrates, all these different systems that Polkadot is expertly implementing. Yeah, I think the reality is that as Polkadot gets closer to reaching its full potential, it makes sense that it has an oracle mechanism that reliably provides data, that reliably takes this problem off of a development roadmap for a dApp or a DeFi product in general. And I think that it's very forward-looking and thoughtful of the Polkadot team to kind of say, okay, like that's going to be a wall that we don't want developers to hit. We want them to be able to get over that and keep building and launching good DeFi, smart insurance, all kinds of fraud-proof gaming, all kinds of applications. And I mean, that's been the basis of the collaboration. We've worked on a lot of integration code in a Chainlink repo. That's kind of an open source resource that's going to be supported by both communities to make sure that the integration and all the capabilities that Chainlink has are properly accessible to all the things that happen in the Polkadot network. And I think it's exciting, and generally speaking, Chainlink is happy to provide all these oracle mechanism data delivery, off-chain trust minimized off-chain computation capabilities to really anybody who's building a worthwhile smart contract. Our goal is to really see this space get redefined into something that isn't just about tokens. It's really about all these other forms of digital agreement and all the value we just talked about them being able to provide. And I think it's great that the Polkadot team sees the value in oracles and wants to provide a high quality oracle mechanism to their developer community, and we're only happy to make sure that they get that reliable oracle mechanism and all the data and capabilities that come with it.
Great. So I'm guessing people aren't going to find you on social media, but where should people go to learn more about Chainlink?
Yeah, so they can go to chain.link, they can go to docs.chain.link, they can go to feeds.chain.link for a lot of our price reference data. We have a Discord community that's very active. There's a lot of support there. We also have a Twitter that is regularly updated with new product releases, new reference data networks, new integrations with data providers, new resources. So I think those are the most common resources. We also have a very active team that seeks to support dApp developers in that a dApp developer can come to us and say, I see the 25 or the 40 price reference data networks you have, but I don't see the one I need. And we'll launch it for them. So we'll be able, if you don't see an oracle or a data provider or some kind of resource that's already integrated into Chainlink, it's very easy for you to integrate it yourself. But if for whatever reason you don't even want to do that, like you don't want to do that last 5% of what it would take to get a good oracle, it's entirely possible that if you contact us and say, look, I'm building this DeFi product, I need this data, we can go ahead and figure out what data source you need. We can give you advice on that. We can help you compose a good oracle network for your use case if it's an uncommon use case. we kind of have almost a solutions part of our team that focuses on thinking about how do we enable a dApp developer to build truly secure end-to-end contract that consumes data correctly. So those resources are very helpful, but I think we are building Chainlink, and we are building all these great tools about oracles, for oracles, and to provide all this data and off-chain computation capability. But I think we also have a part of our organization that can help people think through how to build their dApp the right way. And I want to encourage people and to contact us about that. We respond very quickly. We set up calls with product managers and integration engineers. Our whole project is basically about giving people an oracle mechanism quickly and efficiently, securely, to make sure that they can build this next generation of smart contracts.
Great. Sergey, thank you so much for coming on.
Great. My pleasure. Thank you.
Thanks for listening to Relay Chain. We'd love to keep in touch. Follow us on Twitter at RelayChain or email podcast@parity.io. Our team at Parity includes some of the leading peer-to-peer networking developers, consensus algorithm inventors, blockchain innovators, and Rust developers. If you want to learn more about our work or want to work with us, visit our website at parity.io and sign up for our newsletter at parity.io/newsletter.